In this lesson, we're going to talk about the two transport layer protocols, TCP and UDP. And I'm going to start out with UDP. UDP is a protocol that's used primarily in streaming or real-time communications. And the reason that UDP works best in those types of environments is that UDP is not shackled by a bunch of overhead. And I'm going to explain that in a little bit more detail. At the transport layer, what happens is that communications that is data, which is a large string of bits, and so on. Just imagine how many bits there are in a web page or an email or a streamed movie. And each one of these data segments gets moved down to the transport layer. And at the transport layer, it's broken into segments. And each of these segments gets some port information in the header. So it's from, say, a random port, 5105, as the source. And let's say the destination is a DNS server. So that would be port 53. Each one of these segments is labeled with the source port and the destination port so that they become part of the same conversation. Now, when these actually get transmitted across a network, say like the internet, they may not all go in exactly the same manner. Some of them may get dropped along the way, or they may get put out of order. But in real time, for example, listening to my voice in real time, if we were having an IP phone conversation, if a packet got dropped, we probably wouldn't notice it unless it was a long stream of packets. So basically, for real time, we just allow those packets to take their path from the source to the destination. Say the destination is the DNS server, and for the response to return. We aren't all that concerned about a few packets losing their way or getting placed out of order when they're received, because real time, it's not going to matter, because we're not going to go back and pick up those other things, and the delay to wait would be more disruptive to the communications than losing those few packets. But there are definitely applications where even losing one packet would be catastrophic. For example, in a bank transfer, if we were sending millions of dollars across the internet and we lost a few packets and those happened to be the ones that contained the account numbers, it would be quite upsetting to the people who lost their information. So let's talk now about the other protocol, TCP. When networkers talk about UDP and TCP, they talk about them in terms of reliability. By reliability, what they mean is if packets are lost in a UDP stream, they're not retransmitted, and there's not any worrying going on about whether or not they get there. But in TCP, reliability is built in, not in whether or not any packets get dropped, but in the fact that there's a mechanism that ensures, one, that the fewest number of packets get dropped, and secondly, that if any do get dropped, they'll be automatically retransmitted, that the end user application doesn't have to worry about that. So in TCP communications, we have a source and a destination, just like we did in UDP communications, but each TCP segment has a sequence number in addition to the source and destination port numbers. So for example, if we were looking for a web page, and we were sending the web page request, we would have a source, again, our random port number, and the destination port number would be 80, which is the TCP port assigned to a web server. So we would then have a sequence number assigned to each one of these segments. This is so that when it gets across the internet to the server, that the server will be able to receive those packets and to be able to account for each one. So for example, if this is 1, 2, and 3, and the server has gotten all of them, it would send back an acknowledgement that wanted me to start with sequence 4. So then I would send the next set of packets along the way. Constant communications goes on between the two devices, and this is the overhead I was talking about a little earlier. Constant communications goes on between the two end devices, the source and destination, to determine how many packets get sent before an acknowledgement comes back. In a very reliable connection, eventually this may be hundreds and thousands of packets. In a very unreliable communications, say for example, across the satellite link going all the way across the world, where there's a possibility for many packets to get dropped, the window of packets that goes before an acknowledgement comes in will get smaller and smaller. This guarantees that the fewest number of packets actually get dropped because they're being acknowledged much more frequently in an unreliable connection than they would be in a very reliable connection. So the difference between TCP and UDP is that TCP has an acknowledgement of receipt of the packets. And these sequence numbers also allow the destination host to put the packets back in the order in which they were sent. So it has time to get them in the exact order. Whereas with UDP, there's no acknowledgements and no sequence numbers. Each protocol, though, does have its place in communications across the internet, and it's often the criticality of every packet being received that makes the difference, whether or not the transmission is sent UDP or TCP.